Hello and welcome to Mr. Barton's autograph video number 70, and this week we complete our trigonometric trilogy. Now over the last two videos we've looked at how we can use autograph to really help us practice and consolidate understanding of 2D trigonometry and Pythagoras. And 2 weeks ago in video number 68 we looked at how we could set ourselves up some lovely right angle triangles that would enable our students to practice working out the lengths of missing sides. So in this case here we've got an angle measured, we've got a side measured, and we say to the students, okay, can you measure the length of that side, the hypotenuse in this case. Now the beauty of how we set it up was that we can move points left, right and centre however we want. We'll always get a right angle triangle, and we use this little technique where we actually measured that length but left it in white so we can just reveal it by moving our rectangles over, and it gave us the opportunity to do an infinite number of examples for our students to practice. We did a similar thing with Pythagoras. You've got two sides there. Can your students work out the missing side? And of course things change as soon as you move the angles, move the vertices of the triangle. And then last week in video 69 I think it was, we did a similar thing, but this time to enable our students to practice finding the sizes of missing angles. So in this case here I've got two sides labelled, and I say to the students, okay, can you work out the length of the green angle? When they've got their answer, I just give it a little double click, show label, I got 54 degrees, did they agree? And then if I want to change things around a bit, not a problem, I just change my triangle, hide my angle, and I can have as many different examples as I like. All of which brings us to the final part of this trigonometric trilogy, and that is when students are faced with an isosceles triangle and challenged to work out the length of missing sides and angles in that. And this is a question that I find is gaining popularity in exams these days, and it's tricky for the students because we drum into them the fact that sine, cos and tan works with right angle triangles only, but of course if they can drop down the perpendicular bisector then into an isosceles triangle, then they get the two right angle triangles. So let's have a look how we can study these two important questions using autograph. First things first though, we need to get ourselves an isosceles triangle. Now I set you a little piece of homework last week to see if you can figure out how to construct one in autograph. There are several ways. The way I find the most easiest and the most logical is to use circles, and it's quite useful exercise if you construct this in front of the students, or better still get them to try and construct it themselves, because then it feeds into all their loci construction work. So let's get ourselves a point, and let's chuck ourselves another point into the mix. And what I'm going to do is I'm going to create a circle using these 2 points, with one of them as the centre and one of them as a point on the circumference. So I'm going to select that point, I'm going to select that point, I'm going to right click, and down there I get circle 2 points. Now wherever I move this I'll still have the circle, and that point will always remain on the circumference. So what I'm going to do now is I'm going to pop another point on the circumference down there, and now I'm going to create my triangle. So I've got that point selected, I'll select my centre, right click, and I'll get a little line segment. Do the same thing down here, select, right click, line segment, and select, right click, line segment. And now I'm going to be doing what I've been doing a lot in the last few weeks, and that's hiding things. Going to click on that circle, right click, and I'm going to hide object. And now I've got a lovely triangle which crucially always stays isosceles. And just to emphasize that, I'm just going to make this side the same color as the other side. So if I just make that blue, then it just shows to the students that those sides are the same lengths. Now you can measure them of course using the text box facility, and I'm going to do that now. So same setup, nothing special here. I'm going to measure an angle, so select, right click, and I'm going to have angle. I'll display it to 0 decimal places. I'll make a nice big fat arc size there, so that's 40 degrees, and I will measure a side, so select that, give it a bit of a text box, get rid of distance, not a big fan of that, click OK, and I'm going to say to the students, okay, that's your two pieces of information, that's an isosceles triangle. Now how big is that bit? What's the length of that green bit? And of course we can do our same thing with our white font that we looked at. So if I just click that, measure it, there it is nice and green. But if I give that a quick double click, and if I instead make this white, then it becomes nice and hidden, and I can reveal it when I drag a shape over it, and that will change. Now I've set this up on here. That's what it can look like if you do it nice and neat. So length of blue is 3.4. What's the length of the red? Just drag it. Oh, sorry. Just drag it across, and it comes there, and you can change that left, right, and centre. And that is trigonometry in isosceles triangles. I'll be back with a fresh video next week. Bye bye.